All right, so a marble, a solid sphere, has a mass of 23.5 grams that we're not going to use, and a radius of 1.2 centimeters, which is quite large, but we're not going to use that. And it rolls down a 2.75 meter long incline that loses that much elevation, right? So there it is, rolling down this thing, right? So this distance is 0.65. This is 2.75 meters, right? This thing starts up there, and of course it's we're going to start with the same thing, right? So mgh equals kinetic at the bottom. It's got translational kinetic energy, and it's got rotational kinetic energy, right? Okay, and then it's a sphere, so we're going to plug in. This I is 2/5 mr squared. So you got to look that up, right? Is it a sphere? I'll have that on the assessment. I'll have like all these different moments of inertia, right? You choose the correct one, right? Okay, and actually on these I just tell you what it is in the problem, and it's not one of the standard ones. It's always some weird one that you've never seen before. All right, and then we're going to substitute for omega. Omega is just the linear velocity divided by the radius. Okay, so in our next step we've got mgh. Let's make those substitutions, right? So the 1/2 mv squared comes along for the ride, and then we've got 1/2 times 2/5 times mr squared, right? And then we've got v squared over r squared, right? Because it's 1/2 omega squared, so omega squared would be v squared over r squared, right? Or the quantity v over r squared, right? All right, r squared cancels like that, right? So we cancel the r's, and then we need to combine these terms. The 2's go the way of the bison, interestingly enough. And we've got 1/2 mv squared and 1/5 mv squared, right? Well, that's 5/10 and 2/10. That would be 7/10, right? So that's 7/10 mv squared. I hope you paid attention in fraction world, right? Your calculator will, of course, add those for you. If you go 1 divided by 2 plus 1 divided by 5, right? You end up with this thing, and then you can go math to fraction, and you'll say, oh, that's 7/10, right? Okay, which is kind of cool. So if you can't do the fractions, if you forgot that, why, I don't care if you use your calculator. Okay, you shouldn't have to, though. Right, okay, so now we've got mgh is 7/10 mv squared. Obviously the mass cancels, right? And you end up with v squared is 10/7 gh, right? So the square root of that is v, right? And now we can plug. So once you get the fraction, and I will want you to do that. I want you to tell me what that is. What is that? And then plug the numbers in, right? Okay, so let's plug the numbers into this. That's going to be the square root of 10/7 times 9.81. And then our height is 0.65. All right. 10 divided by 7 times 9.81 times 0.65. Oops, I forgot to square root it, so I'm going to square root it. Okay. And I get 3.018 meters per second at the bottom, right? Okay. Notice that that we naturally get the velocity with energy. Energy never gives you the acceleration, so we've got a suvat for the acceleration, right? And we're going to do that. We know that that's s, right? This is our final velocity, so right, and then our initial velocity is 0. So we can go v squared is u squared plus 2as. 3.018 squared is 0 squared plus 2 times a that we don't know, and then the length of the plane is 2.75. So square the number I've got, divide by 2, divide by 2.75, and I get 1.656. I'm going to say that this is my favorite way to do it. Okay, I encourage you to use energy because it's easy to remember. All you have to do is remember this, and then you just make obvious substitutions. Anyway, there you go.